this is lesson 9.7, identify and perform dilations. So our big question here is, how do you draw or perform a dilation? So one thing that helps me kind of remember what exactly a dilation is if you think about your eyes. Think of your pupils. They dilate, so they get larger and smaller as the light hits them. So that's what a dilation is. It's something that makes the shape larger or it makes the shape smaller. So that's how I personally remember the word dilation. So this frame is 9.7. It's identify and perform dilations. This is about performing dilations and using scale factors. So scale factor is a word you've already heard of. We've already talked about it a bunch, and we're going to use it again in this lesson. So again, this is about performing dilations and using scale factor. So before we go down to our examples, let's fill in this top corner, this yellow box. It's not yellow on yours, but it is in your frame. So scale factor is always the final over the original. Okay, so you put your final shape on top. Whatever number goes from your final shape goes on the top of your fraction, and your original shape goes on the bottom. So that would be P prime, your final, over P, your original. So for scale factor for this lesson, we've got a specific order that we need this in. So let's look at example 1 here. Example 1, remember our scale factor is going to be our final over our original. This says find the scale factor of the dilation and then tell whether the dilation is a reduction or an enlargement. So reduction, it sounds like reduce. If you reduce something, you make it smaller. And enlargement makes it larger. Okay, so let's first look here. First thing you want to do for these is see what's my original and what's my final shape. And we notice that by looking at the letters. See, this is just a plain P, and this is a P prime. Remember, P prime is what we put after we make a change. So this one is our original. Okay? So it got bigger. When something gets bigger, it's called an enlargement. So this is an enlargement. I could do that even before I found the scale factor. And one thing to remember is if you have an enlargement, your scale factor must be bigger than 1, because you've got to multiply it by something bigger than 1 to make it larger. So you might want to put a note right there for an enlargement. Scale factor must be bigger than 1. So keep that in mind. Make sure your scale factor is actually bigger than 1. So our original here, or actually when we make our scale factor, remember we want our final, and the number that we have for our final is 10 over our original, and 6 is the number that goes with our original distance. 10 over 6, that reduces to 5/3. Now 5/3, yes, that is indeed bigger than 1, so it's correct. So our scale factor is 5/3, and it's an enlargement. Let's look at this next one. Again, we want to identify what is our original shape, what's our pre-image, and what's our image. So this one, because it has a plain P, we know that's our pre-image, or our original shape. This P prime, that's going to be our new image. Looking at it, if this is our original, it obviously got smaller, so this is a reduction. So I'm going to put a note up here to remind you for a reduction. If you think about it, your scale factor, I'm going to make a number smaller, you're going to have to multiply it by something less than 1. So your scale factor must be less than 1. Always double check that and make sure it matches up. So for scale factor, remember up here at the top, we're going to do our final over our original. Our final right here is 11. Okay, so it's 11 over our original is right here, that's 22. 11 over 22, well 11 goes into both, that's just 1/2. Okay, so it's a reduction, and by multiplying by 1/2, that makes it smaller. Let's look at the next part of our frame here. Example 5, obviously I skipped a couple examples here. I cut out examples 2, 3, and 4. This one says find the image of a composition. So a composition is when you're putting things together. And we're going to talk about that in class a little bit more. So the vertices of triangle KLM are K, which is -3, 0, L is -2, 1, and M is -1, -1. Find the image of triangle KLM after the given translation, or after the given composition. So first we're going to do a translation. Remember, that's like a slide. So I'm going to first actually graph my original triangle. So K is -3, 0. So -3 zeros right here, that's K. L is -2, 1. So -2, 1 is right here, there's L. And M is -1, -1. Here's M. So here's my shape. I'm actually going to write this out over here. K is -3, 0. L is -2, 1. And M is -1, -1. So I'm going to make a change to this. I'm going to do my translation. And remember, my translation rule tells me I'm going to add 4 to my x's and add 2 to my y's. Okay? So this is after this rule. Whoa, I'm not writing for some reason. X plus 4, y plus 2. I'm going to give myself some space here. So my K prime, if I add 4 to my x, -3 plus 4 is 1. 0 plus 2 is 2. L prime, if I add 4 to my x, I get 2. If I add 2 to my y, I get 3. And then M prime, okay, if I add 4 to -1, I get 3. And -1 plus 2 is 1. And let me just double check that. I needed to add 4 to all of them. I'm looking to make sure that I added 4 to all of them. Then I needed to add 2 to all my y's, making sure I added 2 to all my y's correctly. So I'm going to graph this. So K prime is 1, 2. That's K prime. L prime is 2, 3. That's L prime. And M prime is 3, 1. Now this, okay, was just a slide. It's an isometry. So the shape should look exactly the same. An isometry preserves the size and the shape. So that looks exactly right. So now we want to do a dilation centered at the origin with a scale factor of 2. So when I do this dilation, all I have to do is multiply every single thing by 2. So K double prime I'm going to have, L double prime, and M double prime. And so a scale factor of 2, a dilation with a scale factor of 2, I'm going to multiply by 2. So 1 times 2 is 2, 2 times 2 is 4. 2 times 2 is 4, 3 times 2 is 6. So I'm multiplying all my ordered pairs by 2. 3 times 2 is 6, 1 times 2 is 2. So I've got my new points, I just need to graph them here. So K double prime is 2, 1, 2, 3, 4. So there's K double prime. L double prime is 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. There's L double prime. And M double prime is 6, 2, 3, 4, 5, 6, 2. That's M double prime. And if you look, it looks much bigger, and it should be exactly twice as big. And I'm sure if we actually found the area of both of them, it would be twice as big. So that's how we do a composition. And when we do a dilation, we just multiply by our scale factor. So that is the end of this lesson. Oh, we forgot to, on our frame, so I'm going to go back to the very beginning here. I forgot to put in my so what. My so what here is you should be able to find the scale factors and do dilations. Okay, so you should be able to find the scale factors and perform dilations. So if you have any questions, make sure you start them and we will go over them in class. Any questions at all, we will look at tomorrow, and have a great day. I'm just trying to get this closed here. Have a great day.